Hi everybody, welcome back, and today we are going to be talking about the effects of salinity on the freezing point of water. And this is important because we've been talking a lot about the chemistry of water, right? We are dealing with the fact that the covalent bond between oxygen and hydrogens in the water molecule, they are polar covalent, right? That's what causes the dipoles around the water molecule, the partial positive and negative charges, and that is what begins to form those hydrogen bonds between water molecules. And that leads to a whole property of water list that we went over, everything from cohesion and adhesion, surface tension, high specific heat, all of those sorts of things. Now, in terms of water and ice, liquid water and ice, there's a unique property that happens there as well. Essentially, when you have liquid water, you still have the water kind of moving around, the molecules bouncing around, hydrogen bonds break and form. But as you move from a liquid to a solid, as you decrease the temperature and it freezes, the water molecules, due to that hydrogen bonding, form a bit of a lattice work, and it expands out, increasing the volume and thus decreasing the density. Now, this is very unique because most substances, when you transform from a liquid to a solid, they increase density, but in this case it decreases with water, and thus you find ice which floats in the top of your glass of ice water or on the ocean or forms on the top of a lake rather than freezing from the bottom up. This is really important, and of course the freezing point is generally around 0 degrees Celsius. Now, we are going to be playing around with this because we're dealing with the ocean, and when you put salts in water, you gain another set of properties. They're called colligative properties specifically, but either way, what happens is that changes the dynamic of the freezing point, the point at which water transitions from a liquid to an ice. And that is what we're going to investigate here today. Now, the first thing we want to do is talk about our variables. And in order to do that, we need to understand what it is that we're actually doing, kind of big picture. We're essentially looking at the freezing point of water. Now, you might know already the freezing point of water is at 0 degrees Celsius. So if we add salt into the water, what is that going to do to the freezing point? Is it going to decrease the freezing point, essentially into the negatives, or is it going to increase the freezing point above 0? That's where you get to make your predictions. So let's break this down. What is going to be your independent variable? What is going to be your dependent variable that you're measuring? So remember, independent variable is what you're changing. The dependent variable is what you're measuring, right? What would your prediction be for this situation? If we put salt in the water, do you think the freezing point is going to decrease or increase? Make sure to write that down in your lab. Now, another thing you might want to think about are the control variables. What do you want to keep the same across the board? Now, right off the bat, you can probably come up with a few things, such as the same water, volume of water per experimental group, the amount of salt you're using per experimental group, any other outside factors that you want to keep the same volumetric glassware that you're going to use to measure everything. Those are things that you can consider, and as we move through the experiment, you'll probably better be able to go and fill in what those constant and control variables are. The next thing I want to talk about has to do with molarity. Now, molarity is one way in which we can measure the concentration of solute in a solution. And we can do this by essentially the molarity is the concentration of the amount of substance per unit volume. So how much of this per volume of water? How much of salts per volume water? That would essentially what we're talking about here. Now, we can look at volume in liters, okay, which also happens to be decimeters cubed. Now, I mentioned both of these because you might see both of them in a lab write-up, and they are essentially equal. All right. Now, we will be working with moles per decimeter cubed in this experiment. So that's what we're looking for, molarity per decimeter cubed in our experiment. Now we're going to start getting into the procedures now, and you can follow along in your lab sheet because I have them written down for you. Now the first thing we actually have to do is create an ice bath, all right? And that ice bath is sort of going to give it away. We are going to add about 200 grams of salt, actually not about, exactly 200 grams of salt to about 1,000 milliliters or 1 liter of water, also known as 1 decimeter cubed. Remember, 1 liter and 1 decimeter cubed are about the same. So we're going to fill this all the way up, dump that in. Now, I've sort of already done this just to prep for the lab itself. And we did is put that mixture into ice trays in a freezer. I'm going to give you a clue. It didn't freeze. I actually had to go to the store and get some dry ice, which is frozen carbon dioxide, if you will, to really get the temperature down down enough to be able to freeze this mixture. So here is my slushy mix of ice that's going to be for our ice bath. And this hopefully will bring the temperature down enough to see when ice crystals will form at each of these different molarities. That's the idea. So that's how we're putting together the ice bath. So the next step is to label all of our experimental groups in all the glassware. So we know our 4 levels, right? The 0.5, 1, 1.5, and 2 molar solutions here. And this is where we get beakers. This is a 200 milliliter beaker. I've labeled it with a piece of tape, 0.5, 1, 1.5, and 2. And I've done the same with these test tubes. They all are labeled now. So now that we have them all labeled, we're going to talk about actually how to get the molarity we're looking for. And we're going to do that by adding 100 milliliters of water. Well, I should say this, adding a certain amount of salt per 100 milliliters of water. So that's how we're going to do it. We're going to put 100 milliliters of water in the test tube, right? And this is going to then be, distilled water, so it's nice and pure. And then I'm going to measure out, for example, for a half of mole per decimeter cube, we're going to put 2.8 grams of salt there, so in the mixture. So that's what I'm going to do. I'm going to go ahead and set up for the first round here. Here's my distilled water, which is nice and clean. And I am going to go ahead and pour it and get it to 100 milliliters. There we go. Perfect. Now, I'm going to go ahead. I have my little sample tray. I'm going to zero it out so it doesn't weigh anything, and I'm going to go for 2.8 grams. This is an art. All right, oop. And I got too much. Take it off, oop, too little. Here we go, 2.8. So now I can take this 2.8 grams of salt, mix it in this water, and have a nice little stirring around here at the back end of the spoon. Now this is going to be my half molar per decimeter cube mixture of water, and that is going to go into, where is it? My half a mil test tube. So I'm going to pour that in very slowly. There we go. I did not fill it all the way, that's okay. So now this one is ready to go. So now I just have to do the rest of them. So now we're about ready to begin collecting data. What we're going to do, and if you look at the directions, it'll tell you that we're supposed to take the ice that should be kind of in blocks and put it in a bag, take a mallet and kind of crunch it up to make the ice bath. Well, as it turns out, I can't seem to get the ice to freeze fully, So we use the dry ice. It's in the bag. It's pretty frozen now, but it's still kind of slushed. So we can just pour it directly in. And I have a 500 milliliter beaker. We're going to fill it up to about 400 milliliters with the ice bath. And then we're going to take each of the test tubes with the sample water from each of the different molarities, stick them in the ice bath with a thermometer. And then we will start looking for ice crystals to form. And as soon as ice crystals form, we're going to take the temperature of that particular experimental group, that particular molarity in terms of the solution. That is the plan moving forward. So let's get it started. All right, now I'm going to get the ice bath together here. There we go. Nice and icy, some nice big old chunks of ice in there. Perfect. Now we're going to go ahead and start. We've got our thermometers in the test tubes, and we're just going to line them all up. And here we go. All right, so now we are just watching for the temperature, and we're watching for ice crystal formation. And this one is going to take a bit. So we are still dropping in temperature. We are about, on average, we are below freezing point now on most of them. This is the half a mole of salt, and you can see the temperature right now is about -2 or 3 degrees. The 1 molar solution about -3 degrees. The 1.5 molar solution about -3, 4, almost -4 degrees. And the 2 molar solution is about -6 degrees. Here are some close-ups of the frozen water within the test tubes, and you can definitely see here's a top view as well, how literally solid they froze. All right, guys, that is the lab. Let's take a look at our data. And so at a half a mole, it froze at -2 degrees Celsius. At 1 molar solution, it froze at -3 degrees Celsius. At 1.5, -4, and at 2 molar salt solution there per decimeter cubed, we had it freeze at -6 degrees Celsius. So this was a definite progression, pretty straightforward. And of course, you are going to be, I believe, creating a line graph on this one, so make sure you pay attention to the instructions on your lab sheet. And of course, definitely complete your analysis and conclusion questions. And until next time, keep learning.